Hi, everyone. I have the pleasure today to share with you a study, two experiments in which we investigate the way in which children think about impossible cupcakes and necessary pepper, which is our way to ask whether preschool-age children can deploy the modal concept of possibility, impossibility, and necessity to make sound decisions. Now, modal concepts are concepts that capture notions like necessity, the idea that certain things are inevitable, possibility, which is the idea that some things might happen or might also not happen, and then impossibility, which is the idea that some things didn't happen, but utterly cannot happen. And these kind of modal notions have puzzled and inspired philosophers and logicians, at least since the time of Aristotle, and they might seem extremely abstract and a little bit exoteric and fully detached from our everyday lives. However, I believe that on a second thought, one might realize that modal concepts are in fact pervasive in our mental life, and they are very helpful in a very practical sense. And the reason is that optimal planning and decisions under environmental uncertainty require the discrimination of what could, has to, or cannot happen. So let me give you some example. Think about a train which is guaranteed to have seats. The train is better than one which might or might not have seats, which in turn is better than a third train where sitting is impossible. But now think about the side effects, the undesirable side effects of a flu vaccine, okay? Now a flu vaccine with inevitable, necessary side effects is worse than one which might or might not have side effects, which in turn is worse than one that fully prevents any possible side effects. So in other words, and more in general, all the examples that I presented follow the same general logic. Rational decisions requires to consider both the valence and the modal force of the viable option, whether an option is necessary, possible, or impossible. If an outcome is wanted, then the strongest option is the best one. But if the outcome is unwanted, undesirable, then just the opposite is true. And what I find very striking about this example is that despite the great underlying logical complexity, all of this feels very intuitive, which makes me wonder what is the origin of our capacity for modal judgment and when and how children became able to make decisions that takes into account the modal force of different options. Now, this is an interesting time to study the development of modal cognition, and recent work in developmental psychology has questioned whether young children can make modal judgments at all. To give you an example, in a seminal study by Shilpa Moody and Susan Carey, children younger than the age of 4 years did not show a neat preference for a cup that is guaranteed to have a price inside over cups which might or might not have a price inside. It is only starting from the age of 4 years the children choose the stronger option above 50% of the times. And interestingly, there is also new evidence from the work of Brian Leahy that children might start to learn the difference in meanings between verbs like can and have to, so modal verbs that encode difference in modal force around the age of 4 years. So based on these findings and others, Susan Carey and their collaborators proposed that modal language might be a prerequisite to differentiate what is guaranteed from what is possible or is impossible, making in practice the adult human mind radically different from the one of preverbal children and other not verbal creatures. But an opposite picture for the development and the origin of modal concept is invited by a second line of research proposing that even preverbal infants might harbor uncharted logical resources. So in previous work, my collaborators and I have embedded animated logical riddles in animated movies for babies and found evidence that even infants might be able to draw basic logical inferences, for example, by considering and discounting alternative possibilities. And we have also learned that infants can use these inferences to learn new things, like, for example, the preferences of other people. And the new ongoing research is further uncovering the scope of infants' logical capacity. And if you want to hear more about that, don't miss our lab poster presentations at this conference. tomorrow Maham Fayyaz will present findings about a new core logical representation, which is the concept of order reversal. And on Saturday, Xian Wang will share new striking results that speak about the generality and the flexibility of infants' logical reasoning. But our core logical capacities, interestingly for the topic of this talk, might also support early emerging forms of modal judgment. Indeed, according to an highly influential analysis of modal concepts, categorical modal judgments are the result of the integration of two more basic logical operations. On the one hand, the representation of a space of possible alternative outcomes and logical quantification. Indeed, according to this framework, which is highly influential in logic and philosophy, categorical modal judgments, so according to this framework, I got lost, sorry, an event is necessary when it is instantiated in all of the possible outcomes. It is just possible when instantiated in some, but not all of the outcome. It is impossible when it is instantiated in none of the outcomes. Therefore, inspired by this logical analysis of modal concepts and by the evidence of preverbal logical capacities, my collaborator and I have developed the impossible cupcake task, which is our way to ask whether even 3-year-old children can demonstrate modal judgment, at least under ideal conditions. So in this experiment, we introduce children with probabilistic machines, like the one that you can see now on the screen, and when ping-pong balls are dropped in one of these machines, they can go down any of the 3 ramps. In our task, cupcakes are valuable goals which are placed in some of the ramps to boost the value of specific outcomes. And next, by adding blockers, some possibilities are ruled out while others are left open. And finally, the child is presented with a choice. There is an agent, which is a smiling ping-pong ball, that really, really wants a cupcake. So in which one of the 2 machines must we drop the agent to help her to get the cupcake? Now, if you think a moment about that, the current answer to this question depends on both the modal force of the goal and on its valence. A necessary cupcake is, of course, better than a merely possible one. But a necessary pepper, which in our story is a negative goal that gives tummy ache to the little pimple ball, is worse than a merely possible avoidable pepper. So the question is, can also preschooler reason through all of this? So now one challenge with 4-choice paradigms, like the one that I'm using, is that comparing responses against chance level brings the risk of conflating sensitivity to modal categories with risk-seeking biases. For example, the preschooler suboptimal responses in the 3-cup task that I showed you before might reflect a drive to explore confounded evidence. Like, for example, to see the outcome of like this kind of uncertain hiding of an object in a cup which might or might not have a price inside. Therefore, to operationalize a more robust measure of success and modal judgment, we instead directly compared pair of choices which were logically and probabilistically identical, but were opposite in valence. Because regardless of the potential risk-seeking biases that some babies might have, the relative preference for a necessary benefit over a merely possible one must be higher than the relative preference for a necessary harm than a possible one. So by using this robust measure of modal judgment, we tested 3 kinds of modal contrast: possible versus necessary, impossible versus possible, and improbable versus possible, which were crossed with cupcakes and peppers for a total of 6 trial types, which were presented in a counterbalance order to 24 3-year-old and 24 4-year-old. And crucially, each child in our task was tested with each experimental condition exactly 1 time to avoid learning. So let's start with a choice between a possible goal and a necessary one. We found that both the 4 and the 3-year-old were more likely to choose a guaranteed cupcake than an inevitable pepper, revealing sound decisions between possible and necessary goals. And next, we look at the choice between a possible goal and an impossible one. And we found that children have a stronger preference for an impossible pepper than an impossible cupcakes, like everyone should do. And finally, we look at the probabilistic choice between a 50% probability possibility, and a 33% probability possibility. But strikingly this time, the children struggled to choose the higher probability between two merely possible options. So in summary, in this first experiment, we found that preschoolers can flexibly adapt their choices to goals that are impossible, possible, or necessary, but in contrast, they struggle to discriminate the probability of two possible goals. Now, this pattern of results is actually pretty peculiar, and so we might want to ask, what kind of mental representation might explain the preschooler's modal judgment? And we consider three explanations. The first one is that, of course, an efficient way to make modal judgment is comparing the probability of the two viable options. But intuitive probability judgments, the one that we do in the absence of formal mathematics, have been found to be affected by the ratio of the compared probabilities. And the probabilistic condition in our implementation of experiment 1 is the one with the less favorable ratio, which might explain the preschooler failure. The second explanation that we consider is that children might not compute probability, but use a strategy that we could describe like a one-shot random sampling strategy, meaning that each child might randomly simulate a single outcome for each device and then pick the device with the most favorable outcome. And interestingly, this strategy, when it's iterated across participants or trial, will generate the correct response 75% of the time in the logical condition, but only 58% of the time in the probabilistic one because of the smaller gap in probability in our implementation. So this could explain our results. But finally, a third explanation could be modal concepts, because these concepts highlights the category of necessity, possibility, and impossibility. And therefore, they can explain better performance in the two conditions that cross the boundaries. So to shed light on the representation underlying children modal judgments, we designed a second experiment. In experiment 2, we didn't use blockers, but instead we varied the ratio between goals and ramps. Across three conditions, we had 3 goals out of 3 ramps, 2 versus 2 out of 3, 2 out of 3 versus 1 out of 3, and 1 out of 3 versus 0 out of 3. And crucially, as the results, in all these contrasts, the probability gap is exactly the same. However, only 2 of them cross the logical boundaries of possibility, impossibility, and necessity. So with this setup, we tested 2 new groups of preschooler. And first of all, we found that also this time, the children were more likely to choose a guaranteed cupcake than an inevitable pepper, both the older one and the younger one. And then we look at the contrast between an impossible goal and an improbable one. And again, the children in both age groups had a higher preference for an impossible pepper than for an impossible cupcake. And finally, we look at the contrast between an improbable goal and a probable one. And we found that the probabilistic condition was again the most challenging one for the children. This time, with an easier probability ratio, the 4-year-old succeeded. However, the 3-year-old failed. So in light of this new data, we can ask, how do preschoolers make modal decisions? First of all, our results clearly challenge the one-shot sampling strategy. Remember that in experiment 2, the probability gap is identical across conditions. So the one-shot sampling predicts equal performance across the 3 conditions with a success rate estimate around 66% of the time. However, on one end, the 4-year-old performed well above 66%, and on the other end, the 3-year-old performed better in the logical trials than in the probabilistic one, which rules out the one-shot sampling. And the data also speaks against the probabilistic strategy, because this strategy predicts worse performance in the necessity versus possibility condition, which is the one with the worst probability ratio. However, we found that the preschooler judgment were just not affected by the unfavorable ratio. On the contrary, preschooler robust success in the logical conditions support the proposal that at least from age 3, children might deploy logical concept of possibility, impossibility, and necessity. In contrast, their performance in the probabilistic condition that might reflect a strategy based on the enumeration of the discrete possible outcomes seems to critically improve between the age of 3 and 4. So to conclude, the 2 experiments that I presented today recorded an early emerging capacity for modal judgment with a distinctive categorical character, Now, this categorical character is predicted by the logical analysis of modal concepts. The proposal del modal judgment is the result of the integration of two core logical operations, one which is akin to logical quantification, and the other one to the representation of a space of alternatives. In other words, we are proposing that somehow the children understand that since on the device on your left, as a cupcake in each ramp, if I drop joy in that one, in that device, it is guaranteed that you will get a cupcake. But if this analysis is correct, then the logical resources which are required for modal judgment are in place at least from the third birthday and likely predate the acquisition of modal words, modal verbs, like can and have to. So this is everything. Thank you so much for listening, and thank you for any questions that you might have at this point.
We have time for a few questions.
Thank you for this. It's really interesting. I love this work. I just have a quick technical question, actually, just about experiment 1. In the image, you show the blocker is on the left for the 0.33 versus 0.66.
Yeah, this is just an...
So if it is actually on the left in your studies, there's actually a 2/3 probability that it's going to end up in the yellow case and a 1/3 probability that it's going to end in the blue, because if it hits the left, it's going to roll into the yellow. Which makes the probability comparison 0.33 versus 0.25, or something much closer than you've actually tested, which we know is also hard for 3- and 4-year-olds. So anyhow, you go ahead and do some interesting work in experiment 2, but if that's your actual setup, I just want to draw some argument about the probabilities that it's going to land in the different bins.
Actually, that's an interesting observation. We see the results of experiment 2, and we might ask, maybe with the thing that we are observing might be a result of the specific physical implementation of this probabilistic machine. Maybe probabilistic judgment of infants are very fine-grained and rely on some kind of physical simulation that might take into account this pattern. And I think in that sense, the results of experiment 2 are actually critical, because they might also speaking about this tentative explanation of the categorical pattern that we are observing here. We replicate this pattern even when we remove this asymmetry between the 3 machines. In this case, there is no blocker, so whatever is the probability, the asymmetry in the probability distribution between the true outcome, it doesn't seem to, at that point, is equalized across the three machines in experiment 2.
I don't know if you ran an ANOVA between the 3- and the 4-year-olds on that last trial, but
yes.
They look different to me. I don't know if that's statistically different.
Are you talking about the second experiment?
Just right here. But it just suggests that the 4-year-olds might be solving the task by simulation and the 3-year-olds might not be.
Yeah, actually this is not statistically different. So this is literally what you observe here is the proportion of participants that generated, literally the proportion of participants. We have one single data point for participants here. And of course, we might speculate. We don't know yet whether by increasing the sample size, this is going to flatten out or not. But with this data, that contrast was not significant. In contrast with the other contrasts that I showed you before, they were all very highly significant by using pretty conservative statistical tests.
Hi. Thank you for the talk. Can you go to experiment 2? A question about how robust do you think sort of this logical concepts are to begin with? So because you have sort of a confound, right, of absolute quantity there of the outcomes versus the probabilities. So I was wondering if you were to block, can you go one more slide?
Sorry, but can I ask you, what is your question exactly?
I'll go. What's that? Yeah. So how robust is the logical concept? So if you unconfound probability with the absolute outcome.
Let me think. So, at the end of the day, you can imagine that a very simple creature might make a decision between these 2 outcomes, not by computing probability, the ratio between the open ramps and the cupcake, but you just go to the ramp, to the device that does more cupcakes, right? In that case, what we might expect is that the easiest comparison should be maybe 1 versus 0, then like 2 versus 1 might get a little bit harder, and then like 3 versus 2 might get a little bit harder again. But if you are comparing quantity, whether you are using like some kind of object tracking or enumeration, or whether you are using like a more approximate ratio comparison, I will say that the necessity versus 66 is definitely harder than the other one. But the results that we have is actually a kind of U pattern in which the one in the middle is harder than the other two. So this is clearly showing that they are not counting the cupcakes, that this is not what they are doing. So if the result will turn out differently, I agree that we will not be able to say, is this probability or is the number of cupcake? But it just happened that this is not the data we got, ruling out also the possibility that someone might solve this task by using an heuristic like go to the side where there are more cupcakes without computing the probabilities. Is this addressing your question?
Yeah, I'll continue.
All right, so maybe, Luca, if you want to prepare. I have one last question, maybe very briefly. In your introduction, I think you were framing this. So one question, I guess, is whether you need to have explicit verbal modal markers to do the task or not. But in your discussion, you showed that we can verbalize this task in terms of some, all, no. And isn't that words that 3-year-olds and 4-year-olds do have?
Actually, I think this is an interesting question that I like a lot. I think this is somehow open to future investigation. Is the acquisition of because I've been talking about one type of logical verbal representation with our modal words, but actually there are other logical words in any natural language, like for example quantifiers, a word like all, some, and none. Is the acquisition of this piece of natural language what is determining for success in this task or not? That's an interesting question. And so we don't know, are they using mental quantifiers? Are they using concepts like all, some, and none? Or maybe they are using words to do the task. Nevertheless, whatever device they are using to quantify, they should understand that all the ramps mean guaranteed, which is something that is required somehow to apply those quantifiers on a representation of possibility. At least to understand that the number of ramps in a device is a representation of a space of possibility. Otherwise, I don't see why someone should make these decisions.
Well, thank you very much.
I agree that I think this is maybe what I'm more, is an interesting follow-up to the results.